Hello, welcome to day two. Today's lesson will be on chain rule. Chain rule is when we have functions inside of a function. So for a review, let's talk about the derivatives that we already know. We know all about a constant and the power rule and e to the x, and we just learned about ln of x, and we have our trig circle derivatives. So we're going to use these. So the idea of chain rule is going back to when we did compositions of functions. Okay. So a composition of functions is when we have a function inside of a function. So we have something like this, where f is the outside function and g is the inner function. So let's talk about how we can make things up. So one way we can do things is when we look at sine of 3x, sine of x is the outside function and 3x is the inside function, because if we put this 3x in for that x, we get what we want. So how can we do this? Well, when I look at this example number 1, e raised to the x squared plus 1, x squared plus 1 is the inside function and e to the x is the outside function. So when I put this in for this x, I get what I want. Same thing here. Cosine of x is the outside function and 4x plus 3 is the inside function, because when I put this here, I get what I want, and that's what we're working on. Because next, on the next page, we're going to work on taking derivatives of this stuff. So when I see this example, I have x raised to the 4th is the outside function, x plus 1 is the inside function, and I have 1 over x is the outside function, and 3x plus 2 is the inside function. Again, when I put this in for the x and this in for the x, I get what I want. And finally, as the last two examples, I have 4x to the 5th, and this is 5x squared minus 3x plus 1. And this is ln of x, and this is 3x minus 1. And I'm going to use different words. So instead of calling it x, let me call it something. This basically says f of something is equal to 4 times that something raised to the 5th power, where this stuff right here, the 5x squared minus 3x plus 1, is that something that goes in for that. Same thing here. This goes in for this x. So technically this kind of says f of something is equal to the natural log of something. So my chain rule is going to be applied to these composition functions, f of g of x, where f is the outer function and g is the inner function. So the derivative, or the dy over dx, or the y prime, is going to equal to this very special thing right here. F prime with respect to g times g prime of x. Well, I could also rewrite it as y equals f of something. Y equals f of something. And then my result is going to be y prime is f prime with respect to that something times that something prime. And this is what we're going to work on today. And it doesn't matter if you do outside in or inside out first, we could do it either way. And I'll talk what I mean. So this is what I mean by outside and inside. F and G, F is the outside, G is the inside. I could do the inside part first and then do the outside, or I could do the outside, or I could do the inside later. It's really, as long as, because they are multiplying each other, so it doesn't really matter. So this is, I'm going to have to use chain rule because I have a function inside of a function. I have one function, sine of something, followed by that something equal to 3x. Those are two different functions. So if I take these derivatives, f prime of that something is cosine of u, or cosine of something, and then g prime of 3x is going to be 3, and all I have to do is multiply these together, and I get a final result of y prime equals 3 times cosine of something. But I have to remember that that something that I used, that u value, was equal to 3 to the x. So I rewrite it, where I put in back the 3x for the u, and I get my final result. Okay, let's try one. We have an example right here, and I see that I have f, the outer function, is something raised to the 12th, and when I take its derivative, I get f prime of that something is equal to 12 times u to the 11th. Pretty easy power rule. Next, I see that that something that I used was the inside stuff, 2x plus 1. I can take that derivative, and u prime is just equal to 2. What am I going to do? I'm going to multiply these two links in the chain. I get the whole derivative is equal to 24u to the 11th. And that's what I'm going to put over here. Except I'm not going to write the u any longer. Oh, let me erase. I'm not going to write the u any longer. I'm going to rewrite it as y prime is equal to 24. That u, I should put parentheses around this, 2x plus 1 to the 11th power. That replaced the u. So the way I did this was very mechanical. Another way to do this is just by looking at it. Right now I have 2x plus 1 raised to the 12th, or something raised to the 12th. Some people might say y prime is equal to 12 times that something raised to the 11th, and then I have to multiply it by what is the derivative of the inside stuff? That's 2, so I get y prime is equal to 24 2x plus 1 to the 11th. That's a visual way of doing it. That's doing the outside part first, multiplied by the derivative of the inside stuff, and I get my final result. So that was doing it outside and then inside. I could do the other way. I could say the derivative of the inside is going to be 2 times the derivative of the outside is going to be 12 times that something raised to the 11th, or I get 24x plus 1 to the 11th. Either way it works out, except this time I did the inside stuff first and took its derivative, and then I took the outside stuff second and I took that derivative, and I get my final result. It works out either way. It's really up to you how you want to do it. I'm going to set up my mechanical way of doing it. So the outside stuff is f of something is equal to something squared, and that derivative is equal to 2 times something, and the inside stuff is just 4x cubed plus 1, and that derivative is equal to 12x squared. And when I multiply it all together, I get the derivative is equal to 24x squared times something. Now when I have to rewrite it, I have to get rid of this, because I have to remember that my u stands for something else. So y prime equals 24x squared 4x cubed plus 1. And that's what I get. And that's what we're trying to do. Rewrite it. So on this page, we're going to try to set up what I call mini chain rules. We're going to see that there's a pattern when I take the derivative of sine of something, cosine of something, e to the something, and ln of something. There's going to be a special pattern here that I don't have to go do the formal chain rule every single time. Just follow what the pattern is. So let's try this first example, where the outside stuff is sine of something, and its derivative is going to be cosine, and the inside stuff is equal to 5x, and that derivative is just 5. And when I multiply my box together, I get 5 cosine of u, but that u stood for something else, so y prime equals 5 cosine of 5x when I get rid of that u. So what do you think my conjecture should be? Well, I'm thinking that if I have an extra a up here, my derivative is going to be a times the cosine of ax. Well, let me try. I'm going to move this up just a little bit. Let me try the same thing with cosine. So the outside stuff of this function is cosine of u, and that derivative is negative sine of u, and the inside stuff is equal to 1/2 x, and that derivative is 1/2. And when I multiply my box, I get negative 1/2 sine of u, but now I have to get rid of that u, so y prime equals negative 1/2 sine of 1/2 x. So my conjecture is, if I have an a up here, my derivative is going to be negative a times the sine of ax. And here's the idea. This stuff inside the parentheses, notice the stuff inside the parentheses. I'm going to use my eraser, which is called the argument, never changes for these trig functions. Sine of 5x, I had a cosine of 5x later. Cosine of 1/2 x, I had a sine of 1/2 x later. That's what's going on here. These arguments will not change ever for a trig function. The derivative of a sine of something is going to be something else going on, but a cosine of that same something. Well, let's try this one. So my outside function is e to the something, and that's the easiest derivative of all time, and the inside stuff is just negative 2x, and that derivative is just negative 2. And when I multiply my box, I get y prime is equal to negative 2e to the something, and now I have to rewrite it without the u involved, and I get y equals negative 2e to the negative 2x. So my conjecture is, if I have e raised to an exponent with an a in front of the x, I'm going to get a e to the ax. That is my conjecture. And the idea is that the exponent on e will not change. This is not the power rule where we're always subtracting 1 from the exponent. We're never subtracting 1. So whenever I do the derivative of e to the something, I'm going to have that same something. See, it's the same exponent as before. Now, well, let's try this one. My outside function is the natural log of something, and that's 1 over something, and the something is 3 to the x, and that derivative is just 3. If I multiply it all out, I get 3 over something, and when I get rid of that, I get y equals 3 over, well, that something was 3x, but then I notice they cancel out, so I get y prime is equal to 1 over x. So if you have ln of ax, it seems like its derivative is still 1 over x. That a is irrelevant. Doesn't have any effect. Does not matter. Okay, let's try some more examples on the next page. So I'm going to do all my examples by the mechanical way, outside in. So I have e to the something, and that derivative is e to the something. The inside stuff is 2x cubed, and that derivative is 6x squared. I multiply my box. I get 6x squared e to the u, and now I can get rid of the u, and I get y prime is equal to 6x squared e to the 2x cubed, because that's what the u stood for. And remember, the exponent on e will not change. This next one, I have 7u cubed, and that derivative is 21u squared. And the inside stuff, and I'm going to put parentheses around this, of 2x plus 1, and the derivative is just 2. I multiply my box. I get 42u squared. So I get y prime equals 42, no longer u, 2x plus 1 squared. That is its derivative. Ooh, this seems a little bit more complicated, but I think it's just going to be the same method. The outside stuff is 3e to the something, so the derivative is still 3e to the something. The inside stuff is 2 of sine of x, and that derivative is 2 cosine of x. I multiply my box. The numbers multiply to 6, e to the something. Well, I'll do it the other way. Cosine of x, e to the something. I basically go from the bottom to the top when I multiply, but I do multiply the coefficients. But I have to rewrite this to get rid of the u. So y prime is equal to 6 cosine of x times e to the something, and that something is 2 sine of x. That is its derivative. Next one, I have the same idea. The outside stuff is, well, I'm going to rewrite this as y equals 4x minus 5 to the negative third. That would help me out a lot. And then I could say the outside stuff is something to the negative 3, and its derivative is negative 3, something to the negative 4. The inside stuff, and notice I put parentheses around things when there's more than one term there. The inside stuff of 4x minus 5, its derivative is just 4. And when I multiply the box, I get negative 12u to the negative 4th power. So my y prime is equal to negative 12. This is the u, 4x minus 5 to the negative 4. Not so bad. Now this next one, I'm going to have to move it up. Well, we got this one here first. We pick a different color. The outside stuff is 2 times the ln of something, and that's going to be 2 over something. And the something is 5x minus 2. Notice I put parentheses around it, and that derivative is 5. I multiply these together, I get 10 over u, or y prime is equal to 10 over, this is the u, 5x minus 2. Everything we've been doing with this chain rule has been really 2 links in the chain. Well, what happens if we have more than just a function inside of a function? What happens if we have a function inside of a function inside of another function? So this is really what I should have changed it here. 3 links in a chain. Okay, everything else has been 2. We've been multiplying 2 things inside of a box, but now we're going to do even more. So the outside function, f of u, is 3 sine of something, and that is going to be 3 cosine of something. Well, the next thing I see is u is equal to something else squared. Well, let me erase this. So there's another function inside here. If you look carefully, I have a function here, a function here, and a function here. So u is a function of a different letter, which is something squared, which is w. I have to use a different letter. I can't always use u squared. Oops, sorry. That's not right. That's not its derivative. It's 2 times that something. And then finally, I have w is a function of x, and that's just going to be 2x cubed plus 5x minus 1. Parentheses around it because there's more than one term, and that derivative is going to be 6x squared plus 5. And notice I need to put parentheses around it. Okay, now I have 3 links in my chain. I'm going to use, so I'm multiplying these 3 links. I do the coefficients first. 3 times 2 is 6. I usually go from the bottom to the top. 6x squared plus 5 times w times cosine of u. And remember, this is the w, and this is the u. So when we rewrite this all, I get y prime is equal to 6x squared plus 5. You don't have to distribute. W, which is 2x cubed plus 5x minus 1, times cosine of this whole thing, 2x cubed plus 5x minus 1 squared. This is its derivative. Notice, the argument for trigonometry did not change. This is the same argument. Okay, that's a little bit more work. Ask questions in class. Like I said, these are my video notes. I'll hopefully you were there in lecture. Thank you for watching.